Download this code from codegive.com, link in the description below. Combining vulnerability and threat data with Secureworks Taegis, a detailed tutorial. This tutorial explores how to combine vulnerability data from various sources with threat intelligence from Secureworks Taegis to enhance security posture and proactively address risks. We'll cover different data sources, ingestion methods, data enrichment techniques, and practical code examples using Python and the Taegis API. Why combine vulnerability and threat data? Individually, vulnerability data identifies weaknesses in systems, and threat intelligence describes malicious actors, their tactics, techniques, and procedures, ttps, and indicators of compromise, iocs. By combining these two data sets, you gain a more comprehensive understanding of your organization's risk landscape. This integration allows you to prioritize vulnerabilities, focus remediation efforts on vulnerabilities that are actively being exploited or are associated with threats targeting your industry or geography. Identify exploitable vulnerabilities, cross-reference vulnerability data with exploit databases, like ExploitDB, and threat intelligence to determine which vulnerabilities have readily available exploits. Detect active exploitation, monitor for iocs associated with the exploitation of specific vulnerabilities identified in your environment. Improve threat hunting, use vulnerability data to guide threat hunting activities, focusing on systems with known vulnerabilities and potentially compromised assets. Enhance incident response, quickly identify affected systems and vulnerabilities during security incidents, allowing for faster containment and remediation. Overview of steps. 1. Data sources and preparation. Vulnerability data, discuss common sources, vulnerability scanners, vulnerability management platforms, and data formats. Secureworks Taegis data, overview of Taegis threat intelligence feeds and how to access them. Data standardization and enrichment, converting data to a common format and enriching it with context. 2. Ingestion and storage. Methods for ingesting vulnerability data into a storage solution, database, data lake. Accessing Secureworks Taegis threat intelligence via the API. 3. Data correlation and analysis. Techniques for correlating vulnerability data with threat intelligence, matching CVEs, affected products, iocs. Using queries and scripts to identify high-risk vulnerabilities. 4. Integration with Secureworks Taegis. Pushing enriched vulnerability data to Secureworks Taegis for improved visibility and incident response. 5. Automation and reporting. Automating the entire process for continuous monitoring and risk assessment. Generating reports and dashboards to visualize vulnerability and threat data. 1. Data sources and preparation. 1.1 Vulnerability data sources. Vulnerability scanners. Example Neshes, Qualys, Rapid7 Insight VM. Regularly scan your network and systems to identify known vulnerabilities. Output formats vary, example Neshes, .Neshes, Qualys, XML, Rapid7, CSV. Data typically includes CVE, common vulnerabilities and exposures, IDs. Vulnerability severity, CVSS score. Affected host/asset. Port/service. Vulnerability description. Remediation recommendations. Vulnerability management platforms. Example ServiceNow vulnerability response, Kena security. Aggregate vulnerability data from multiple sources and provide workflow and reporting capabilities. Often integrate with vulnerability scanners and patch management systems. Typically provide a more structured and normalized view of vulnerability data. Software Bill of Materials, SBOM. A list of components of a software application. Useful for understanding the components and associated vulnerabilities in your software supply chain. Formats, SPDX, CycloneDX, SWID. Manual vulnerability assessments. Performed by security experts to identify vulnerabilities that automated scanners might miss. Results are typically documented in reports. 1.2 Secureworks Taegis data sources. Secureworks Taegis provides a wealth of threat intelligence data through its API and web interface. Key data sources include Threat Intelligence Feeds Counter Threat Unit, CTU, feeds provides in-depth analysis of threat actors, campaigns, and malware. IOC feeds supplies indicators of compromise, IP addresses, domains, file hashes, URLs, associated with known threats. Adversary profiles contains information about specific threat actors, their TTPs, and targeted industries. Security events security events generated by Taegis XDR, extended detection and response, or other integrated security tools. Events can indicate potential security incidents and provide context for vulnerability exploitation. Vulnerability intelligence Taegis can provide a correlated view of vulnerabilities and associated threat actor activity. Accessing the Taegis API. You'll need an API key to access Secureworks Taegis threat intelligence. Obtain this from your Secureworks account representative or through the Taegis portal. The API is a RESTful API, allowing you to interact with it using standard HTTP methods: GET, POST, PUT, DELETE. 1.3 Data standardization and enrichment. Before combining vulnerability and threat data, it's crucial to standardize the data formats and enrich the data with additional context. Standardization convert data from different sources to a common format, example JSON, or a database schema. Ensure consistent naming conventions for fields like host name, IP address, CVE ID, and vulnerability description. Enrichment CVE enrichment use the National Vulnerability Database, NVD, API or other CVE databases to retrieve detailed information about each CVE, example CVSS score, description, affected products. Exploit database enrichment check exploit DB to see if exploits are available for identified vulnerabilities. Threat intelligence enrichment use Secureworks Taegis API to check if specific vulnerabilities or affected products are mentioned in threat intelligence reports. Asset context enrichment add asset metadata, example business criticality, department owner, to vulnerability records. 2. Ingestion and storage. 2.1 Vulnerability data ingestion. Choose a storage solution based on your data volume, query requirements, and existing infrastructure. Common options include relational database example PostgreSQL, MySQL. Suitable for structured data and complex queries. Use an ORM, object relational mapper, like SQL Alchemy for easier data access. Data lake example Amazon S3, Azure Data Lake Storage. Asterisk suitable for large volumes of unstructured or semi-structured data. Asterisk use tools like Apache Spark or Apache Hive for data processing and analysis. Asterisk Elasticsearch asterisk. Asterisk suitable for full text search and real-time analysis. Asterisk integrates well with Kibana for visualization. Here's a Python example of ingesting vulnerability data from a CSV file into a PostgreSQL database using SQL Alchemy. Explanation asterisk. 1. Import libraries asterisk imports necessary libraries for CSV parsing, database interaction, SQL Alchemy, and datetime manipulation. 2. Database configuration asterisk defines the database connection string, database_URL. Important asterisk replace the placeholder credentials with your actual PostgreSQL credentials. 3. Define data model asterisk defines the vulnerability class, which maps to the vulnerabilities table in the database. Each attribute in the class represents a column in the table. The data types correspond to the CSV and Postgres data types. 4. Create database engine asterisk creates a SQL Alchemy engine that connects to the database. 5. Create session asterisk creates a database session, which allows you to interact with the database. 6. Ingest_vulnerability_data function asterisk. Asterisk takes the path to the CSV file as input. Asterisk opens the CSV file and uses csv.dictReader to read the data as dictionaries. Asterisk iterates through each row in the CSV file. Asterisk creates a vulnerability object for each row, mapping the CSV columns to the corresponding attributes in the class. Asterisk adds the vulnerability object to the session, staging it for insertion. Asterisk error handling asterisk includes a try, except block to handle potential errors during row processing and insertion. This prevents the script from crashing and allows you to log errors. It also ensures that the session is rolled back if an error occurs, preventing partial data insertion. Asterisk committing changes asterisk after processing all rows, it attempts to commit the changes to the database. If any errors occur during the commit, it rolls back the session. 7. Example usage asterisk. Asterisk sets the CSV_file_path variable to the path of your vulnerability data CSV file. Asterisk calls the ingest_vulnerability_data function to ingest the data. 8. Close session asterisk closes the database session. Before running this code asterisk install SQL Alchemy pip install sklalchemy psychopage2 binary. You may need to install a database driver like psychopage2 binary for PostgreSQL. Create the CSV file create a CSV file named vulnerability_data.csv, or whatever path you specify, with the following headers and sample data. Create the PostgreSQL database and user create a PostgreSQL database and a user with the necessary privileges to access the database. Make sure you update the database_URL with the correct credentials. 2.2 Accessing Secureworks Taegis Threat Intelligence. Use the Taegis API to retrieve threat intelligence data. You'll need your API key for authentication. Explanation 1. Import libraries imports the requests library for making HTTP requests and the JSON library for working with JSON data. 2. Get_Taegis_threat_intelligence function takes your Taegis API key and a CVE ID as input. Constructs the API endpoint URL. Important replace https://api.secureworks.com/threat-intelligence/v2/cves/cve_id with the actual API endpoint for retrieving CVE-related threat intelligence. Consult the Secureworks Taegis API documentation for the correct endpoint. Asterisk sets the request headers, including the authorization header with your API key and the content type header to specify that you're sending JSON data. Asterisk makes a GET request to the API endpoint. Asterisk error handling asterisk uses response.raise_for_status, to raise an exception for HTTP error codes, 4xx or 5xx. This simplifies error handling. Asterisk parses the JSON response from the API. Asterisk returns the JSON data. 3 example usage asterisk. Asterisk sets the API_key variable to your Taegis API key. Important asterisk replace your _Taegis_API_key with your actual API key. Asterisk sets the CVE_ID variable to the CVE ID you want to query. Asterisk calls the get_Taegis_threat_intelligence function to retrieve threat intelligence. Asterisk prints the JSON response to the console, using JSON.dumps for pretty printing. Asterisk handles the case where no threat intelligence is found. Before running this code asterisk install the requests library pip install requests. Obtain your Taegis API key get your API key from your Secureworks account representative or through the Taegis portal. Verify the API endpoint double check the Secureworks Taegis API documentation for the correct endpoint to use for retrieving CVE-related threat intelligence. The example endpoint may not be the most accurate. Look for endpoints related to vulnerability intelligence, indicators, or threat actor activity. Example Taegis API response, illustrative. 3. Data correlation and analysis. Now comes the crucial part, correlating vulnerability data with threat intelligence. 3.1 Correlation techniques. CVE matching the simplest approach is to match CVE IDs between your vulnerability data and the Taegis threat intelligence feed. This identifies vulnerabilities that are known to be actively exploited or associated with specific threat actors. Affected product matching if Taegis threat intelligence mentions specific products or software versions being targeted, match those against the software inventory information associated with your assets. This helps identify systems that are vulnerable to targeted attacks. IOC matching match IOCs, IP addresses, domains, file hashes, from Taegis threat intelligence against your network traffic, endpoint logs, and other security data. This can help detect active exploitation attempts. Vulnerability score correlation use the vulnerability CVSS scores, base, temporal, environmental, in conjunction with threat data to prioritize remediation. Vulnerabilities with high scores, actively being exploited by a known threat actor, get prioritized. 3.2 Example correlation logic, Python. Explanation 1 Correlate vulnerability threat data function takes a list of vulnerability data dictionaries and a list of threat intelligence dictionaries as input. Creates an empty list high risk vulnerabilities to store the vulnerabilities that are considered high risk. Iterates through each vulnerability in the vulnerability data list. Extracts the CVE ID from the vulnerability. CVE matching it uses next and a generator expression to efficiently search the threat intelligence list for a matching CVE ID. The next function returns the first item in the iterable that satisfies the condition, in this case, item CVE_ID equals CVE_ID. If no matching item is found, it returns none. Asterisk if a matching threat underscore info item is found, meaning the vulnerability is mentioned in threat intelligence. Asterisk prints a message indicating that the CVE is mentioned in threat intelligence. Asterisk threat actor analysis asterisk checks if the threat underscore info dictionary contains a threat underscore actors key. Asterisk if threat underscore actors exists, it iterates through each actor in the threat underscore actors list. Asterisk it checks the confidence level of each threat actor. If the confidence is high, it prints a message indicating that the CVE is actively exploited by a high confidence threat actor. Asterisk the vulnerability dictionary itself is then appended to the high underscore risk underscore vulnerabilities list. Asterisk CVSS prioritization asterisk checks if CVSS score is greater or equal to 7, high severity rating, then it gets added to the high underscore risk underscore vulnerabilities. Asterisk finally, the function returns the high underscore risk underscore vulnerabilities list. 2 example usage asterisk. Asterisk provides example vulnerabilities and Taegis underscore threats lists. Important asterisk replace these with your actual vulnerability and threat intelligence data. Asterisk calls the correlate underscore vulnerability underscore threat underscore data function to correlate the data. Asterisk prints the list of high-risk vulnerabilities. 4. Integration with Secureworks Taegis. After identifying high-risk vulnerabilities, you can push this information to Secureworks Taegis to enrich its threat detection and incident response capabilities. The specific method will depend on the Taegis services you're using. Here are some possibilities. Asterisk custom security events asterisk create custom security events in Taegis based on the identified high-risk vulnerabilities. These events can trigger alerts and be used for investigation. Asterisk IOC upload asterisk if the analysis reveals new IOCs, example IP addresses associated with exploitation attempts, upload these IOCs to Taegis to improve detection. Asterisk enrichment data asterisk add custom enrichment data to assets in Taegis, indicating the presence of specific vulnerabilities. Example, pushing a custom security event to Taegis, illustrative. This example assumes you have a function create underscore Taegis underscore security underscore event that handles the API call to create a custom security event. The exact API call will depend on the Taegis service you are using. Refer to the Taegis API documentation for details. Explanation asterisk. 1 push underscore vulnerability underscore data underscore to underscore Taegis function asterisk. Asterisk takes your Taegis API key and the list of high underscore risk underscore vulnerabilities as input. Asterisk iterates through each vulnerability in the high underscore risk underscore vulnerabilities list. Asterisk create event data asterisk constructs a dictionary event underscore data to represent the custom security event. This dictionary contains information about the vulnerability, the affected host, and the time of the event. Customize this event underscore data structure to match the requirements of the Taegis API endpoint you're using. The example includes asterisk event underscore type, a string identifying the type of event, example high-risk vulnerability detected. Asterisk timestamp, the current timestamp in ISO format. Asterisk source underscore host name, the host name of the affected system. Asterisk source underscore IP, the IP address of the affected system. Asterisk CVE underscore ID, the CVE ID of the vulnerability. Asterisk CVSS underscore score, the CVSS score of the vulnerability. Asterisk description, a description of the vulnerability. Asterisk severity, the severity of the event, example high, medium, low. You might set this based on the CVSS score or the confidence level of the threat actor. Asterisk details, a more detailed description of the event. Asterisk threat underscore actors, list of the threat _actors if available, using .get to prevent errors when the key does not exist in the vulnerability dict. Push to Taegis calls the create Taegis security event function, which you need to implement based on the Taegis API, to push the event to Taegis. Prints a message indicating whether the push was successful or not. Important notes implement create Taegis security event you need to implement the create Taegis security event function to make the actual API call to Secureworks Taegis. Consult the Taegis API documentation for the correct endpoint, request format, and authentication methods. API endpoint make sure you use the correct API endpoint for creating custom security events in Taegis. Data mapping carefully map the data from your vulnerability records to the corresponding fields in the Taegis security event structure. Error handling implement robust error handling to catch potential API errors and ensure that the data is pushed correctly. 5. Automation and reporting. 5.1 Automation. To make this process sustainable, automate the following tasks. Vulnerability scanning schedule regular vulnerability scans using your vulnerability scanner. Data ingestion automate the ingestion of vulnerability data into your storage solution. Threat intelligence retrieval schedule regular updates of the Taegis threat intelligence feed. Data correlation and analysis automate the correlation and analysis process to identify high-risk vulnerabilities. Taegis integration automate the process of pushing vulnerability data to Taegis. You can use tools like cron, Ansible, or a dedicated orchestration platform to schedule and manage these tasks. 5.2 Reporting. Create reports and dashboards to visualize vulnerability and threat data. This will help you track your progress, identify trends, and communicate risks to stakeholders. Examples of reports include: Top vulnerabilities list the most common or critical vulnerabilities in your environment. Vulnerabilities by asset show the vulnerabilities affecting specific assets or departments. Threat actor targeting identify which threat actors are targeting your organization and the vulnerabilities they are exploiting. Remediation progress track the status of vulnerability remediation efforts. Vulnerability age show the length of time a vulnerability has been outstanding to highlight overdue remediation. Tools like Kibana, Grafana, Power BI, or Tableau can be used to create interactive dashboards and reports. Example: building a dashboard in Kibana. 1. Index vulnerability data index your vulnerability data in Elasticsearch, if you are not already using it. 2. Create visualizations bar chart show the top vulnerabilities by count. Pie chart show the distribution of vulnerabilities by severity. Map show the location of affected assets, if you have location data. Data table display the raw vulnerability data. 3. Create dashboard combine the visualizations into a dashboard. Conclusion. Combining vulnerability and threat data with Secureworks Taegis provides a powerful way to improve your organization's security posture. By automating the ingestion, correlation, and analysis of this data, you can proactively identify and address risks, enhance threat detection, and improve incident response. Remember to consult the Secureworks Taegis API documentation for the most up-to-date information on API endpoints and data formats. Adapt the code examples provided to your specific environment and data sources. Continuously monitor and refine your processes to ensure they remain effective as your environment and the threat landscape evolve.